So generally, to describe motion of an object, the first thing we must be able to tell is its position. Okay, we all know that. When object was moving on a straight line, we fixed an origin somewhere, and based on the distance from the origin and the side on which it is, positive, negative, we were telling its position, like plus 10 meters, minus 4 meters, and so on. Because to describe position on a straight line, one coordinate is sufficient. You just need to tell on which side of the origin and at how much distance. But to describe motion in a plane, okay, plane, as you know, is two-dimensional geometry. So suppose there's an object somewhere here. To describe its position, okay, we have talked about this earlier also, you need two coordinates. Okay, you need two reference lines first. We call them as the reference axis. One as x and one as y. Then to describe its position, we describe the position, or we describe the distance from the y-axis and the distance from the x-axis. Okay. In the first quadrant, x is positive, y is also positive. In the second quadrant, x coordinates will be negative, y coordinates will be positive. Third quadrant, both x coordinates and y coordinates will be negative. And in the fourth quadrant, x coordinate will be positive and y coordinate will be negative. So by mentioning x coordinate and y coordinate, we can specify the position of the object in a plane, right? So whenever you need to describe motion of an object in 2 dimensions, you will choose a reference frame like this. Okay. Of course, after solving many problems, you'll get used to finding out the answers without taking the reference frame itself. But for now, whenever we want to describe anything, we'll fix a reference frame first. Okay. So we have to take a coordinate system like this, right? So as I said, the first thing we need to describe is the position of the object. By specifying coordinates, you can tell its position, that's fine. But there is something called a position vector. As the name suggests, it's a vector which indicates the position of the object. Okay. And how do we draw this vector? Usually, position vector is a vector drawn from the origin to the position that you want to indicate. Okay. For example, if you want to indicate the position of this particle, you draw a vector from origin to that position like this. Okay, let's say this point's coordinates are x comma y. Some x coordinate, some y coordinate. Okay, let's say 2 comma 3, 5 comma 2, anything. Okay. So the vector drawn from the origin to the point whose position you want to describe, this is what we call as its position vector. Okay. Can any of you tell me, like, if its coordinates are x comma y, let's take an example value here. Let's say 10 comma 6. If the coordinates are 10 comma 6, can any of you tell me how much is the x component of this vector? How long will this be? Like, how many units will that be?
Sir, 10.
10 units. That is what we call as x coordinate. Okay. This is 10 units in which direction? Positive x, positive y, negative x, negative y. What direction is this green arrow in?
A positive x.
It's clearly visible. It's in the positive x direction. What is the standard unit vector in the positive x direction?
I cap, sir.
I cap, correct. So you write this component as 10 I cap. Okay. Next, if you consider a vector like this, can any of you tell me how long that will be? What is the length of that vector? Length or magnitude? The point's coordinates are 10 comma 6. Based on that, you tell. How long is that orange vector?
For 6 units.
6 units. And it's in which direction?
Positive y.
Positive y. So how will you write it as a vector mathematically?
Plus 6j.
6j cap. Okay, correct. So this 10 I cap and 6j cap are nothing but the x component and y component of that position vector R. So you can write the position vector r as 10 I cap plus 6 j cap. This is something we learned in the last class. A vector can be expressed as the sum of its orthogonal components taken in the same plane. Orthogonal means perpendicular. Now we took one component along x-axis and one component along y-axis. They are perpendicular only. Okay. So the original vector r can be expressed as the sum of these two. Now let us generalize this. If see for 10 and 6 we got 10 I cap plus 6 j cap. Then in general for x comma y, Aishwarya, you tell me, if the coordinates are x comma y, how do you write the position vector?
Sir, xi cap plus yj cap.
Good. Xi cap plus yj cap. That's all. So that's how we describe the position of an object in 2 dimensions. You will need 2 components. Sometimes the point may lie on the x-axis, then only x component will be sufficient. Y component will become 0. That is also possible, but in general, you will need 2 components. That's what I'm saying. Okay. Let's solve one question based on this. Nishita, can you tell the definition of displacement? We had discussed this earlier.
The shortest distance covered with respect to time.
No. Proper definition of displacement. Okay, Vanilla, can you tell the definition?
The change in position.
Change in position. Correct. Okay. From now, like just stop saying shortest distance. Shortest distance between 2 points is the magnitude of displacement. That's not the displacement itself. Displacement is a vector quantity. If you say shortest distance, you are only indicating distance, not direction. Okay. But displacement is supposed to include direction. Okay. So fine, take this as -5 comma +4. So let's say there's an object, it starts from A and then goes to B and finally goes to C. Just a moment. Okay, let's take C somewhere in the 3rd quadrant. Third quadrant, both are supposed to be negative. So x component, let's say -5. Y let it be 16. Okay. Right. So it goes from A to B and then from B to C. So tell me, what is the displacement as it goes from A to B? What is the displacement from B to C? What is the total displacement of this object? And what is the magnitude of total displacement of this object? And is the magnitude of total displacement equal to distance covered? Okay. So I'll give you 1 minute to answer all this. Remember the definitions. See, this may seem like a question out of nowhere to some of you, but just recollect the definition. Displacement is change in position. You know, first position is A, second position is B. Change means final minus initial. So write the positions, write the position vectors and then subtract them. Okay, I'll give you a brief idea how to subtract vectors. It's obvious. Suppose there's one vector like this. Let's say x1 I cap plus y1 j cap, and another vector like this, x2 I cap plus y2 j cap. If you want to add them, just add the x components. It becomes x1 plus x2 I cap plus y1 plus y2 j cap. That's how you add vectors. And if you want to subtract them, x1 minus x2 I cap plus y1 minus y2 j cap, and that's all. Okay, so you'll have to use that here because displacement is change in position. Change means final position minus initial position. So for each displacement, write the initial position vector, final position vector, and subtract them. You'll get the displacement vector. Okay? Do it quickly, all of you. Okay, Aishwarya, what is the displacement vector from A to B?
So minus 15 I cap plus 8 j cap.
How did you get plus 8 j cap? Tell me, what is the position vector of A?
Sorry, so minus 15 I cap.
Position vector of A is 10 I cap plus 4 j cap, and position of B is minus 5 I cap plus 4 j cap. So when an object goes from A to B, B becomes the final position, A is the initial position. If you subtract them, minus 5 I cap minus 10 I cap becomes minus 15 I cap. And then 4 j cap minus 4 j cap becomes 0. That means the displacement from A to B doesn't have a y component. It makes sense. You imagine the object going from A to B, it's only going like this, right? The displacement is only along the x direction. It doesn't move in the y direction at all. Okay, overall there is no change in position in the y direction. Its y coordinate is not changing, no? That means there is no displacement in the y direction. So this is the displacement from A to B. Okay. Next, Vanilla, what is the displacement from B to C? Tell me the position vector of C first.
Sir, minus 5 I cap.
Hmm.
Minus 16 J cap.
Minus 16 j cap. Correct. So how do you write the displacement vector when the object goes from B to C?
Minus 20 J cap, sir.
Okay, you just have to subtract these two. Subtract the x components. Minus 5 I cap minus 5 I cap becomes 0. And subtract the y components. Minus 16 j cap minus 4 j cap becomes minus 20 j cap. Yusuf, is this clear? Any doubt in this? Any of you, if you have any questions, you can ask. The second displacement from B to C is only in the y direction. It doesn't have any x component at all. That's why we got the answer as minus 20 j cap. Okay. Can any of you tell the answer for total displacement now, all the way from A to C? Total displacement all the way from A to C. Nishita?
Yes, sir.
Any answer for total displacement? You just have to do the overall final position minus overall initial position. That is one way to do. That means position vector of C minus position vector of A. That can be done. Otherwise, you can do first displacement plus the second displacement. That will also become total displacement. So you can solve whichever way you want. Tell me the answer quickly.
Minus 15 I cap, minus 20 J cap.
That's all. Total displacement is minus 15 I cap minus 20 J cap. In whatever units you can write meters. Okay. Is this third part clear to all of you? Any questions in that? You just do overall final position minus overall initial position, or you add individual displacements. Okay. So what you get is this, the vector from A to C. That's the complete displacement vector. Okay. This green one is minus 15 I cap. The orange one, since it is pointed downwards, it's a minus j cap, so minus 20 j cap. And the black one is the sum of those two. Okay. You can see the tail of the orange one is at the head of the green one. Then the resultant will be drawn using the triangle law, and you can see the triangle forming on the screen. So this is minus 15 I cap minus 20 j cap, the sum of those two vectors. Okay. Now we need the magnitude of displacement. This we had discussed in the last class. If there's a vector like this, having some x component and y component, how do you calculate its magnitude? Anyone? If you know the components, how do you tell the length of the vector? Come on, you all didn't practice the worksheet at all. I gave you some 6 to 7 questions based on magnitudes, angles made with the x-axis, y-axis. Yeah, Pawan, go ahead. You wanted to say something.
Sir, root of x square plus y square.
It will be root of square of the x component plus square of the y component. See, this is what I told you in the last class, no? You have to solve the worksheet. Vectors is a very important thing. I mean, as we go through the chapters, it will become comfortable for you. But this chapter, if you have to solve it, I mean, understand and solve thoroughly, you should be comfortable with vectors. And we discussed in the last class, if a vector has components, some ax I cap, ay j cap, then its magnitude will be root of ax square plus ay square. Okay. If it's simply xi cap plus yj cap, then it is root of x square plus y square. Okay. So here I asked you the magnitude of total displacement. Now we got the vector total displacement. Calculate its magnitude, all of you. Yeah, Saket, your answer is correct. Vanilla, your answer is also correct. One correct. Okay. It's just square root of 15 square plus 20 square. Whether you take plus 15 and square it or minus 15 and square it, it's going to become 15 square only. So you'll get it as root of 625, which is 25 meters. That's the magnitude of total displacement. So you can say, see, some of you have learned that, or in your lower classes, you definitely would have learned that displacement is the shortest distance between 2 points. This 25 meters is the shortest distance between A and C. Okay, this vector's length is actually 25 meters. But that 25 meter doesn't convey the direction. Minus 15 I cap minus 20 j cap conveys the direction. Okay, minus 15 minus 20, it exactly tells you which way the arrow should point. And it tells you the magnitude also. You can calculate magnitude from it. Okay, so displacement is actually change in position, but the magnitude of displacement is the shortest distance between 2 points. Okay. Now one of you tell me, you know how the object has traveled. It went from A to B and then from B to C. So in this total displacement, is the magnitude of displacement going to be equal to distance? We had discussed when distance will be equal to magnitude of displacement in the last class. And you know what is distance and what is magnitude of displacement. For this particle, are they equal?
No, sir.
Why not?
Sir, because the object is not traveling in one direction.
Correct. Correct. The object has changed its direction. If an object ever changes direction, distance will not be equal to magnitude of displacement. Which one will be greater? Okay, not which one will be greater. In this case only, let's say it went straight from A to B, then straight from B to C. That's what the object did. Yusuf, tell me, how much is the distance covered by this object? What distance did it actually move?
So from A to B and then from B to C.
Total.
Yes, sir. Minus 15i and minus 20j.
See, minus 59, minus 20j are the displacements. I'm asking you what is the distance moved by the object as it goes from A to B to C. How much distance did it actually move? What is the total length from A to B to C?
35.
That's all. 15 plus 20, that is 35 meters, correct? Okay, distance covered is nothing but the length of the path traversed by the object. So 15 plus 20, for distance, direction does not matter. So 15 plus 20, 35 meters is the distance. And magnitude of displacement is only 25 meters. Why are they not equal? Because the object changed direction. Okay. So whether it is 1D motion, 2D motion, generally, if object changes direction, distance and magnitude of displacement are not going to be the same. Okay. So in this question, there are a few things that we learned: how to add vectors when they are given in component form, how to subtract vectors, how to take its magnitude, and if positions are known, how to calculate the displacement, right? Can one of you tell me, okay, put this question aside now. Can one of you tell me the formula for magnitude of resultant of two vectors? Suppose the individual vector magnitudes are known and the angle theta between them is known. How do you calculate magnitude of the sum of two vectors?
Root of a square plus b square plus 2ab cos theta.
Correct. A square plus b square plus 2ab cos theta. Now, if there are only two vectors whose resultant you need to find out, you can use this. But what if there are more than two vectors? Can this be used? Definitely not. This formula involves magnitudes of two vectors and the angle between them. If there are more than two vectors, you cannot use this. Okay, it's obvious. But in many situations, it's quite common. It's quite common to come across multiple vectors that need to be added. For example, there may be multiple forces acting on an object, and you may have to find out the combined effect of all those multiple forces. Fine. So let's see what to do in such cases if there are more than two vectors to be added. Okay. So let us discuss it as a question. An object moves, let's say, 5 meters due east. Due east means towards east. Okay. And then let's say 8 meters due north. And then 11 meters due west. Okay. So 3 separate displacements of the object are given to you. So first thing I want you all to do, draw the path. Okay. Means draw the diagram indicating how the object moved. Draw the path. Next thing I want you to do is express each displacement as a vector. Means you have to write it in mathematical form in terms of I cap or j cap or both. Fine. Then calculate total displacement. That's all. Yeah. So listen, this is a question giving you some real life motion, describing some real life motion of an object, some displacement towards east, some due north, due west and all. So what you need to do is first assign those directions. Let's call this as east. This becomes north, west and south. Okay. We know north is west, so that's fine. But now we have to make it mathematical. Okay, in order to add and find out the total displacement, we have to make it mathematical. So what you can do is consider one of those directions as the x-axis. Let's call east as x, north will be taken as y, west becomes negative x, south becomes negative y. That's how you make the situation mathematical. Okay, go ahead, solve this question, all of you. Okay, I hope all of you have drawn the path. 5 towards east, 8 north, then 11 west. Let me do that. 5 towards east will be towards right. So maybe somewhat like this. Then 8 meters due north. So after this displacement, the next displacement is 8 meters due north. So after this 5-meter displacement ends, the 8-meter displacement begins. So diagram will go like this. 8 meters due north. Then 11 meters due west. West is to the left as seen from our point of view. And 11 should be longer than 5 and 8. So, okay. So this is what the person has done. Let's call these points as A, B, C, and D. Right. So A to B is 5 meters. Direction is given. B to C is 8 meters. Direction is given. C to D is 11 meters. Direction is given. Okay. So this is what has happened. Now we need to express each of them as a vector. Means you have to write it in terms of I cap, J cap. So draw the coordinate system first. Now it doesn't matter where you take the origin. Fine. These are displacement vectors, change in position. So it doesn't matter where you consider the origin. Let's take it like this. Assume this is the coordinate system. It's not a rule that you have to take it like this. You could have taken the coordinate system like this with the origin at the point C. You could have taken coordinate system like this with origin at the point A. Nothing wrong in that. Whichever way you solve, you will get the same answer. Okay. I'm taking it like this. I'll assume the origin is here. This is the positive Y direction and this is the positive X direction. So, the person started from somewhere, the object started from somewhere A, and then the displacements are as shown. Okay. Now we have to express each of these displacements as a vector. Nishita, you tell me, in terms of X and Y, in which direction is that 5-meter displacement? In which direction is the 5-meter displacement? Okay, anyone else? In terms of X and Y.
Positive X direction, sir.
Positive X. What is the unit vector in the positive X direction?
I cap.
I cap. So how do you write that displacement A to B in terms of I cap and J cap?
5 I cap, sir.
Good. 5 I cap. Okay. Hope this is clear to all of you. That displacement from A to B is 5 I cap. Saket, tell me, how will you express the displacement from B to C in terms of I cap and J cap?
8 J cap.
8 in the positive Y direction. So 8 J cap. Good. Yusuf, can you tell the displacement from C to D?
So minus 11 I cap.
Very good. Minus 11 I cap. It is in the negative X direction. So minus 11 I cap. Correct. Now you are asked to calculate the total displacement. Okay. Now total displacement is the vector from A to D, as you can see. Let us draw that vector. So one of you tell me how to calculate this overall displacement. Total displacement, how to calculate? You listen. Here, we don't know the exact position of A. Okay, I took origin randomly. Some of you may have taken origin at origin at A. Some of you may have taken the origin at B. So we don't know the exact positions. Okay, so this time if you want total displacement, you can't write final position minus initial position. Then what is the other way to calculate total displacement? Add the individual displacements. You will get total displacement. That's all. So tell me, what is the sum of these three displacement vectors? Aishwarya, tell me.
Sir, 2.
What two? These are vectors, they have directions, I cap, j cap and all. How can you ignore them? I didn't ask, no, I asked you the sum of these displacement vectors. You can't add them like
Sir,
numbers. Ha,
so minus 6 I cap plus 8 j cap.
correct. It will be minus 6 I cap plus 8 j cap. And that is this black vector. Okay, the final displacement vector. Okay, hope this is clear to all of you. Now, suppose you want to find out the magnitude of total displacement. You already have the total displacement vector, just take its magnitude. Tell me the magnitude of this vector, all of you. Quick.
Ten, sir.
It will be 10 units. Square root of 6 square plus 8 square becomes square root of 100. That is 10 meters. So observe what we have done here. There were 3 vectors and we got the magnitude of resultant of 3 vectors. Okay. And not just 3. This way you can add any number of vectors. So this formula, root of a square plus b square plus 2ab cos theta, it has very limited application. What is the limit? It's applicable only to magnitude of 2 vectors, magnitude of the resultant of 2 vectors. But if there are more than 2 vectors whose overall magnitude you need to find out, then this is the way to proceed. Express them mathematically, I cap, j cap form. You can add any number of vectors that way and get the final resultant's magnitude. Okay, so keep this in mind. Now listen, the original question was in terms of real life directions like east, west, north, south. In exams, when they give you questions like this, they expect the answer also in real life directions only. So if they ask you, like suppose in exam, they tell you that object moves 5 meters due east, then 8 meters due north and 11 meters due west. And they'll ask you what is the total displacement. You are expected to give the magnitude and direction in terms of these only. North, east, west, south. Okay, not in terms of I caps and j caps. And if you observe, I cap, j cap is something we introduced for our convenience here to make the displacements mathematical and find out the resultant displacement. Okay, so these are tools that we used, I cap, j cap and all. But the final answer should be expressed in terms of how the question is expressed. So the task now is to express this final displacement vector in terms of north, east, west and south, not in terms of I cap, j cap. Let's see how to do that. So we have the final displacement vector in hand. We don't need all these. Okay, let it be. Total displacement we know is minus 6 I cap plus 8 j cap. That's what we got, no? Right. In meters. We got the magnitude of displacement also. It is 10 meters. Now we have to specify that direction. Okay. So now we will not be using xy anymore. We'll have to use north, east, west and south. Okay. So x will be east, y will be north. Then to the left will be west. Can one of you tell me in which direction is that displacement or total displacement A to D? how does it look? Saket, you tell me, in which direction does that displacement appear to be? Northwest. But I told you one point when we started discussing motion in a plane. It has only if it makes 45 degrees, then you can call it northwest. This vector may not make 45 degrees. Okay, so let me take that vector aside for a moment. Let's fix the origin at the tail of that vector. It doesn't matter where you fix the origin. So let's take it like this. Okay, this vector is minus 6 I cap plus 8 j cap. Now it doesn't have equal x component and y component. So do you think it will be making 45 degrees? No, it will not. Okay, so it's not exactly northwest. This is north, this is west. It's not exactly in between, so it's not northwest. Can anyone tell me an idea to describe its direction? Okay, I'll tell you anyway after some time, but if you have any way to express that direction, you can share. Anyone? Tell me an idea to indicate that direction. Suppose you want to tell someone to move that way. How will you tell?
Sir, 6 meters due west and 8 meters due north.
Okay. Fine. You can say that. You can ask them to move 6 meters west, then 8 meters north. Okay. But what we want to express is, we know the overall magnitude of this displacement, no 10. I want you to tell it this way. 10 meters along which direction we should move. That is my question. How to describe that direction?
Sir, we can find tan theta.
You can find out the angle it makes. Good, correct. Okay. So yeah, that's the way to do it. So what you can do is, you can either find out the angle it makes with the northward direction, or find out the angle it makes with the westward direction and tell that angle. Fine. And to tell that angle, you should first visualize the components. We know that the x component, it is minus 6, but magnitude is 6 units. Okay. And the y component, its magnitude is 8 units. You have to visualize these always. Vector is there, you have to automatically visualize its components. So 8 this way and 6 this way. 6 to the left, so minus 6 actually. Okay. So on this side, this will also be 8 and this will be 6. Suppose you want to tell the angle with the west direction, this one. Let's call this as alpha for now. Now you see that the y component and x component are perpendicular. Definitely they are perpendicular. And x component, y component and the vector, they always form a right angle triangle. That is what makes expressing these angles easy for us. Okay. So one of you tell me, how much is alpha? I'm not asking the exact value, but you can see the sides of the triangle, right? 8, 6 and 10. In terms of that, using some trigonometry, tell me how to express alpha. It's a right angle triangle, so you can use some trigonometric ratio and involve that angle alpha. So how can it be expressed?
Sir, tan theta.
You want to write tan alpha. Okay, no problem. So Pawan, you tell me, how much is tan alpha in the triangle?
Sir, 53 degrees.
Ore, నేను అడిగిన tan alpha. Alpha కాదు.
8 by 6.
Opposite by adjacent. 8 divided by 6, 4 by 3. And I gave you one sine cos table, right? In that, if you get tan, you will see that tan 53 degrees is 4 by 3. Okay. That means the angle alpha becomes 53 degrees now. See, this part you will get used to it, don't worry. But we got the angle with the westward direction now. Okay. So one of you tell me, how will you describe that 10-meter displacement in words now? It is 10 meters along which direction? We got the angle also, just use your knowledge of English and describe that direction. Okay. Yusuf, if you want to tell someone to move 10 meters in that direction, how will you tell? Like they know north, east, west, south. Okay. And you want to tell someone to move at that angle, how will you tell?
So like northwest or like so I'll say so people use degrees no sir.
Yeah, 53 degrees you can use.
So some people use clock also no sir, like they say 3 o'clock or some things like that.
53 degrees is not exactly 3 o'clock. It's not
No
exactly.
sir. So this is like 11 o'clock or like 10:30 sir. Like that.
Then you'll have to find that exact time.
Uh,
No, just in terms of that 53 degrees you tell. Suppose they have protractor also, they can measure the angle. So how will you tell them which way to go?
the diagonal.
Diagonal won't work. Diagonal could be like that. It could be like this. It could be like this. Okay, anyone else?
Sir, 53 degrees due west.
See, due west means towards west. So due is like towards. So you can't say 53 degrees towards west. You can say 53 degrees from west, not due west. Okay. So you can call this displacement as 10 meters at an angle 53 degrees from west or with westward direction. You can say that. But there is a problem here. If you say 53 degrees with west, the person may go that way, the person may go this way also. This angle also is 53 degrees. There are two 53 degrees possible, no? Upwards and downwards, like that side and this side. How will you specify the exact direction? Okay. Let us first consider this. Suppose there is a straight line. Assume there are two objects on it. Yeah. Let's say this is A, this is B. Assume the separation between them is 20 meters. Assume this is the eastward direction and this is west. There's no origin, only A and B are there. Yusuf, you tell me, how will you describe the position of B if the position of A is known?
So 20 meters from A.
Do you think that will be sufficient? 20 meters
So
from A could be here, it could be here also.
20 meters to the right of A.
Correct. 20 meters to the right of A. Listen, we all know this. This is general English. But there is some physics involved in this. You are describing the position of an object, right? So 20 meters is the magnitude. Right is the direction. A is the reference. Generally, whenever you want to specify position, all these should be there. Magnitude, direction, reference. Okay, so all those are seen here. So this also means 20 meters to the right from A. Okay, like starting from A, you go 20 meters to the right. That is what it means. So A is actually where you start from. Fine. Now in this case, this angle alpha, we got it as 53 degrees. Let me remove these numbers just to make it easy to see. We got this angle as 53 degrees. That angle 53 degrees is from which direction? Or with which direction is that angle 53 degrees? See and tell directly, with what direction is that displacement making 53 degrees?
West, sir.
With the west. Okay. So it is 53 degrees from west, you can say. Towards, starting from west, you have to go 53 degrees towards which direction? We say 53 degrees towards north. Okay, it's like this. 53 degrees towards south would have come like this, in this direction. That's not what we want. Okay. So here, the starting direction is west. Just to get the proper direction of displacement, from west you rotate by 53 degrees towards north. Okay. So how can we mention this angle in words? You can say it is 53 degrees. Like here, how did we describe B's position? We said B is 20 meters to the right of A. Means from A you have to go towards right. Then you say right of A. Here, from west you have to go towards north. So you say north of west. That's the proper way to describe this direction. Okay, you call that angle 53 degrees north of west. Means starting from west, you rotate by 53 degrees towards north. Then you will get the proper direction. That is what it means. Is this clear to all of you? Did you understand how to specify direction in terms of north, east, west, south? Okay. Tell me how you will describe this direction. Type in chat, don't unmute. Okay, I got 3 answers so far. All 3 are correct. Yusuf, right? Okay. Yusuf, unmute yourself. We'll discuss. How much is the angle?
So 30 degrees.
30 degrees. From?
So from east axis
towards?
the north.
From east towards north. How do you convey that? You can say from east towards north also, but how to do it this way? Like in the previous,
So 30 degrees east from north.
30 degrees east from north would be like this.
So then 30 degrees east of north or north of east.
They are different. Which one it is you have to finalize.
So 30 degrees north of east.
Correct. North of east. It means north from east. Okay. Right. Nishita, is this clear? Okay, fine. So this is how you describe directions in terms of angle made with one of the standard reference directions, like north, east, west, south. Okay. And what we just saw is how to add or how to find out the resultant of more than two vectors. Okay. Whether they are displacements or forces, whatever it is, if you want to find out the resultant, express each one of them mathematically first, then get the overall resultant mathematically, then take its magnitude. Let's try one more problem like this. Suppose there's an object on which multiple forces are acting. Forces are vector quantities, okay? So just treat them as vectors. Let's say there's one force acting to the right. How much shall we take? Just a moment. Okay, let's say 6 units. 6 newtons. Newton is the SI unit of force. Then another force, 10 newtons, and it makes an angle 37 degrees with this 6 Newton force. Okay. Fine. And another force. Let's take this one to the left, or not left. Let's take it at some angle like this. At what angle is it acting? 53 degrees. And how much is it? 5 newtons. Okay. So these three forces are acting on this object. I want you to find out the magnitude of the net force, means the magnitude of resultant of these three vectors. Try this, all of you. The previous question was slightly easy compared to this one, because in the previous question, the displacements were strictly towards east, strictly towards north, strictly. So only I caps or J caps were there. But this time, the forces have both X and Y components. So take the components carefully. You can name the forces as F1. They're vectors, so we'll put a bar on them. F2, F3. Express them mathematically first, then add them and take the magnitude. That will be the magnitude of resultant. Okay. So you can imagine an x-axis and a y-axis if required, and write the components carefully. Do it step by step, all of you. Vector by vector, you express it in terms of I cap and J cap. Just a moment. So you can imagine the coordinate axis like this. You know what angles the vectors are making with x-axis or y-axis. Based on that, you write their components. I got one answer as 11 Newton. No, that is not correct. Or maybe I should say it's an incomplete answer. No. Eleven is one part of the answer. Aishwarya, your answer is correct only. Find out the magnitude. Okay, let's discuss. Yusuf, how will you write the force F1 in terms of I cap, J cap?
The distance is unknown, right, sir?
What did you say?
So distance to, so it'll be I cap only, sir. Positive I cap.
And it's a 6 Newton force. So how do you write it as a vector? Its magnitude is 6. Direction is I cap. You just write it as 6 I cap Newtons. Okay? Simple. Yusuf, you only tell me this 10 Newton is not exactly along the x direction, not exactly along the y direction. So if you want to express this 10 Newton mathematically, you will have to split it into components and write it as the sum of those components. Okay. So tell me, how much is the x component of that 10 Newton force? X component, if you visualize, see, how do you draw components? You drop the projection from the tail onto whichever direction in which you want component, and you draw projection from the head also. Now the 10 newtons tail is already on the x-axis. From its head, if you drop a projection, this becomes the x component of that 10 Newton force. Okay, and you drop a projection onto the y-axis, you will get the y component of that 10 Newton force, and that will be like this. So we have visualized the components, okay, but now we have to express them mathematically. So Yusuf, can you tell me how long this is going to be? The original vector's magnitude is 10. So how much will be the magnitude of that x component?
So 10 I cap.
No. If that original vector is 10, then how will this be 10? Do they look like same length? They're of the same length. Definitely not. The component is shorter than the original vector. How do
So
we
it's just, so it's a little bigger than the F1, sir.
forget about F1 now? Yeah, it is bigger than F1, but we can't take F1 as the reference, no? Based on F2 and the angle it makes with x-axis, you have to tell the component. Because if F1 had not been there also, you should be able to tell the component. So, and also these are freehand diagrams, so you can't say it will be bigger than F1, shorter than F1 also. How do you calculate the component of a vector in a particular direction? There's a formula for it we had discussed earlier. Okay, anyone? How to take the x component of this vector?
10 cos 37, sir.
That's all. Any vector whose magnitude is a, if you want its components along some component along some direction with which it makes an angle theta, then the component simply becomes a cos theta. You should know the magnitude of the vector and the angle it makes with the direction along which you want the component. Now the direction along which we want the component is the x direction here. Of course, we want y also. First, we are taking the x component. The angle that 10 Newton makes with the x-axis is 37 degrees. Then this component becomes 10 cos 37 degrees. And cos 37 degrees is 4 by 5. 10 into 4 by 5 becomes 8 units. So you will write this as 8 I cap. Okay. Again, in the last worksheet, there are many questions like this. You are supposed to do those. Okay. Pawan, tell me how to calculate its y component. Be careful. You have this habit of using sine. If you want to use sine also, use the correct angle. Okay. And tell me the component carefully in the y direction.
Sir, minus 5 cos 53.
Minus 5 cos 53. Why did you put a minus sign?
సార్ అంటే y axis లో నెగిటివ్ సైన్ అంటే కిందకి డౌన్వర్డ్స్.
యాడ కిందకి ఉంది అది పైకే కదా ఉంది arrow, blue color arrow in the y direction, it is pointing upwards.
సారీ సార్ నేను F3 చెప్తున్నా.
No, I am asking F2's y component. The 10 Newton's y
10
component. 10.
10 sin 53.
Why did you take sin 53?
Sir, 90 minus 53.
90 minus 37 is 53. Okay. So the angle it makes with y-axis is 53 degrees. Why did you use sin?
సార్ cos 90 మైనస్ సార్ అంటే cos అప్పుడు 90 మైనస్ అయినప్పుడు sin అవుతుంది కదా.
No, you tell in terms of cos. So you are saying you should take cos 90 minus what?
ఓకే సార్
10
10 cos 90 minus 37.
10 cos of 90 minus 37, that is 10 cos 53. Okay, that will be the component. See, I'm telling you this again, always use cos only and always take the angle between the vector and the direction in which you want the component. So if you want a component in the y direction, don't use this angle at all. Forget that angle. you have to use this angle if you want angle component with y direction. If you want component in the x direction, you will use 37. If you want component in the y direction, you will use 53 and always use cos. Okay. Anyway, 10 cos 53, 10 into cos 53 is 3 by 5. This becomes 6 units. And it's in the positive y direction, so that becomes 6 j cap. So 8 I cap is one of its components, 6 j cap is the other component. So Aishwarya, tell me how to express that vector F2 in terms of I cap j cap mathematically.
Sir, 8 I cap plus 6 J cap.
Correct. Newtons. Okay. Now there's another vector we have to deal with, the third one. Same procedure we will follow. Let us visualize its components first. If you imagine its components, no, then you will know whether to put a plus sign or a minus sign. Okay. So if you want x component, project it onto the x-axis. If you project it onto the x-axis, the x component looks like this. It is pointed to the left. Okay. Let us calculate this component first. Vanilla, tell me, how much will that be and how will you calculate?
Sir, 5 cos 53.
That's all. Magnitude is 5. With that direction, it makes 53 degrees. So it simply becomes 5 cos 53. 5 into cos 53 is 3 by 5. So effectively becomes 3 units. But it's 3 to the left side. So Vanilla, how do you write it as a vector? It's mathematical form.
Sir, minus 3 I cap.
Correct. Minus 3 I cap. That is one of its components. Next, the y component, if you want, project the vector onto the y-axis. It's like this. Tails projection to the head's projection. Yusuf, first, how much angle will the vector make with the y-axis?
37.
37 degrees. Okay. Then how much is this component? You know the vector's magnitude, you know the angle it makes. So tell me the component's magnitude.
So 5 cos 37.
Correct. 5 cos 37. Cos 37 is 4 by 5. 5 into 4 by 5 becomes 4 units. Okay. Make it a vector now. Magnitude is 4. Assign a direction to it.
So minus j
Correct.
cap j cap is.
Correct. So Yusuf, continue. How do you express that vector F3 now completely? We got its components.
So minus 3 I cap plus minus, also minus 4 j cap.
Plus minus becomes minus only. So minus 4 j cap Newton. Correct. Correct. So these are the three forces expressed mathematically. I'll remove all this. Right. Now the question asked you to find out the resultant force's magnitude. So we'll first get the resultant force. We call that as the net force or the effective force acting on it. Pawan, tell me the sum of all forces.
Sir, 5i plus 2j.
How did it become 5i?
Sir, 8i minus 3i.
పైన 6 లేదా మొత్తం 3 forces ఉన్నాయి కదా. Add all 3 forces, not 2. We want the sum of
11.
F1 plus F2 plus F3.
Sir, 11i plus 2j.
You add all the x components. 6 plus 8, 14 minus 3 is 11 I cap. And y components. The first force didn't have a y component, so it's 0. Second one had 6, third had minus 4. 6 minus 4 is plus 2 j cap. So 11 I cap plus 2 j cap newtons is the net force. And if you want its magnitude, it will be square root of square of x component plus the square of y component, that is square root of 125 newtons. You can write it as 5 root 5 because 125 is 25 into 5. 125 you can take outside the square root. So 5 root 5 newtons is the net force, magnitude of the net force. Okay. Anyway, see, this is not exactly motion in a plane. We included forces here. Forces we'll talk about in the next chapter, laws of motion. I'm just telling you how to find out the resultant of multiple vectors, more than 2. Okay. So what all have we learned today? How to write the position of an object in a plane. Okay, position vector. How to calculate displacement, how to calculate magnitude of displacement. Then we discussed how to add multiple vectors and get their resultant. Fine. So next class, we will see how to describe some other quantities like velocity, acceleration. Now see, if you know velocity, then you can tell displacement. Okay, from velocity, magnitude of velocity is speed. You can calculate the speed. With speed, you can tell the distance, such things. Okay, so basically, whatever we discussed in kinematics in a straight line, all those kinematics we'll discuss in a plane now. But when writing or when describing motion in a plane or when expressing these quantities, velocities, accelerations, displacements in a plane, you'll have to use components. Okay, so that's the extra thing that we will include in this chapter, how to take components and find out all those things. Okay, we'll continue on Wednesday. And tomorrow also I'll send you a worksheet mostly based on addition of vectors, expressing that angle. Like today we saw that 53 degrees north of west, 30 degrees. So some questions based on that, total displacements, and see basic definitions. Like we know average velocity is total displacement by total time. Now today you learned how to calculate total displacement. By adding multiple displacements, you can tell total displacement. Then you can simply divide it by time and tell average velocity. Okay, so such questions also will be there. Fine, practice thoroughly. And those of you who have not solved the vectors worksheets, do those first. Okay, take printout and solve those worksheets. Otherwise, if you want, you can draw also, your choice. Okay, thank you all. We'll continue on Wednesday.
Thank you, sir.